Hey gang, today we're going to look at what is a function. So we have been working with a lot of functions, dealing with equations. Now you need to be able to look at a set of values and know whether it represents a function or not. So as discussed in previous lessons, a function is the work done to a number put into an equation to get a number out. It is the rule that assigns to each input exactly one output. So what that means is each value of the x can only be paired with one value in the y. You can't have x, one value of x, be paired with more than one value of y. Because if you put something in an equation for x, you can't get out more than one answer. You can only get out one answer. So as long as each x is only paired with one y, it's going to represent a function. If an x value shows up more than once and is paired with more than one y, then it is not a function. So let's see how this happens. Here's some examples. Number one, students are tracking the height of a kite in the sky as a function of time it has been in the air. The data recorded is shown below. So time in the air is our x or our input, and height is our y or our output. And you can see that the time in the air is recorded in intervals of 10 seconds and that none of those times show up more than once. So we have 10, 110, 120, 130, 140, 150, 160, 170, 180, and 190. It's not like 10 shows up twice or 60 shows up twice. And then we have height above the ground, 5, 8, 14, 22, 30, 22, 34, 40, 22, 0. Now that does go up and down a little bit, okay? And there are some y values that show up more than once, but that is okay. So let's take a look at what they want us to do. List the input and output to this function. It should say output. So the input are 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. The outputs are 5, 8, 14, 22, 30. I already listed 22, so I don't have to list that again. 34, 40, already listed 22, don't have to list it again, and 0. Okay, so part B, list the outputs for each of the following inputs. So if we have an input of 30, we get an output of 22 feet. If we have an input of 60, we have an output of 34 feet. Each of those inputs only matches one output. So, based on this definition of a function, is height of the balloon a function of time? Explain. So here we could say yes, height of balloon is a function of time because for each time recorded, only one height is recorded. And that makes sense. It would not make sense for the balloon to be at two different heights at exactly the same second. So this would be a function. All right, let's take a look at another example. Number two, 10 middle school boys record their heights as shown in the table below. So we have their age, 12, 12, 13, 13, 13, 14, 14, 14, 15, 15, and then their height in inches, a whole bunch of different numbers. Part A, list the input and output to this function. So our input, we have 12, shows up more than once, 13 shows up more than once, 14 shows up more than once, and 15 shows up more than once. Then our height, we have 60, 68, 65, 70, 62, 64, 67, 72, 66, nothing's repeated yet, and 74. Okay, so I had to list them all because there are no repeats. Part B, list the outputs for each of the following inputs. So for 13, we have three 13s and we have three different outputs. So the input of 13 is giving an output of 65, 70, and 62. And then the input of 15 is giving out two outputs of 66 and 74. So now, because these inputs have more than one output, this cannot be a function. So based on the definition of a function, is height a function of age? When looking at a group of people, no. Height of a group of people is not a function of time, since people of the same age have different heights. Which is like saying there are inputs that have more than one output, which cannot happen. Okay. I would not be able to plug in an age into an equation and get out a height based on that equation for every single person that exists, because everybody has their own way of growing. All right, so hopefully you're understanding what I mean by here. Again, the key is that each input can only be assigned to one output, or each part of the x can only be assigned one y. All right, so if an x shows up more than once, it is not a function. If each x only shows up once, it is a function. All right, so you guys are now going to try numbers 3 and 4 on your own. Check in with me so I can be sure that you're getting them right before moving on to your exit ticket, and then you can start your homework.